Hey guys, this is video number 4 of our 9.3 section. This is going to be the two-sided test and confidence interval. Okay, so basically what the two-sided test does is you have either greater than or less than, we don't care which it is, but we're thinking that it's going to be one of these two, okay? So what we have is our null hypothesis is equal to our parameter, okay? And then our alternative hypothesis is when our mean does not equal our parameter. Okay, so what we're going to do is, since it's basically the same conditions that we have and what we're going to be working with, is we're just going to start with an example. Okay, so I shortened it down a little bit from the long narrative that they gave to us. Basically what it is we're looking at the child's game, Don't Break the Ice. And what it is it's just a game, and it's got these little cubes. Okay? So the cubes are obviously made out of ice, and then what happens is you take those cubes and you slam them or smush them into a square frame. And then what happens is you get a hammer, not an Allen wrench, but a hammer, and you tap ever so gently the cubes of ice out, and hopefully when you tap that cube out, the floor doesn't collapse, and the polar bear, I think, is saved and everything's fine. So it was teaching the children all about global warming and saving the polar bear's ice. Conspiracy theory. So basically what happens now is we don't want the cubes to be too big, because if the cubes are too big, then they won't fit in properly and the kids will have a hard time putting it together. If the cubes are too small, then the cubes obviously won't fit into the square rectangle or the square frame, and they'll just fall out and everybody will be grumpy and upset. So what we know is that the machine that produces the cube is designed to make cubes that are 29.5 millimeters wide, but the actual width will vary. Okay, everything will just vary because that's kind of what makes the game fun. So we're looking at 29.5 because it's a cube. That means that all the sides are 29.5. Okay, so what we have is we have a supervisor that inspects a random sample of 50 cubes every hour and measures their width. Okay, the following is a summary of their findings, and the mean is 29.4846 millimeters. The standard deviation is 0.090027 millimeters, and then the standard error is 0.0127318, and of course our size n is 50. That will be nice when we have to do our conditions, correct? Okay, so we are first to interpret the standard error and standard deviation, and then what we're going to do is we're going to answer the question, do the data give convincing evidence that the mean width of cubes produced this hour is different from 29.5 millimeters. Okay, now just kind of thinking ahead, brainstorming what we got to do with part B is we need to make sure that our 4 conditions are met, and then we're also going to have to decide what's going to be our significance level. And really, because this is not life-threatening or really financially threatening or anything like that, we're probably going to use a significance level of 0.05. Okay, so what we're going to do, hopefully you've already paused it and you've already gone through it, but I'm going to scoot this down again and give you a chance if you haven't had a chance to get it written down. Okay, great thing is they didn't give us a list that we'd have to type in our calculator. That's where I was going. So we just have to calculate it once we've done the standard error and standard deviation. Okay, so let's look at the standard error and standard deviation. Okay, so let me scoot this down for us. So let's look at standard deviation first. So if you remember, a standard deviation is going to be the width of the cubes vary, I'll make sure I get it all in here, vary about, where'd my paper go? 0.09002 millimeters from the mean and the mean was 29.4 from the mean of 4846 millimeters. Okay, and then the standard error. So the standard error is when we're taking our sample. Okay, so what we're going to say with this one is in a random sample, and we did 50. The sample mean will typically be off by 0.0127 millimeters from the true mean. Okay? All right. So again, this is part A. So the standard deviation is going to look at how far we're from kind of the population type of things, the way you can look at it, even though it's our sample. And then we're breaking up into there. The standard error is if we continue to do a random sample of 50 cubes, we will typically be away from the true mean about 0.0127 millimeters. Okay? Now, part B, we need to start doing our conditioning. Okay? Now, we really can't start doing our null hypothesis or alternative hypothesis until our conditions have been met. Okay? So the independence one cube manufactured won't affect the other. Okay, and then let's see here, let's go to random, and that was stated. And then we have itch my nose real quick. Okay, and then we have a 10% condition, and our 10% condition is just going to be 50 less than or equal to 1/10 of the entire population. So if we have 500 cubes, making sure this game's nationally sold and everything like that, I'm pretty sure that we are okay with continuing on. So 500 cubes made, you know, there are a lot more than 500 cubes made. Anyway, there's a lot more. Okay, that pen was bad, so I don't want to use it again. Okay, so then we go to the last one, which was our large numbers, and that's going to test our normality again. And because n is greater than, 50 is greater than 30, we can use, oh my gosh guys, I'm sorry, we can use CLT and proceed with our test. with a t-test. Okay? Which is nice. That's test. Okay. All right, so we have this. Now we need to state our null and our null hypothesis and our alternative hypothesis. Okay. What was it 29.5? All right, so I'm going to stop it there, pick it up in the next video. I'm just almost out of time. So, okay, see you in a couple minutes.